In this lecture, we have been talking mainly about the bytecode. We have got here initial instructions, init code from our faucet smart contract, and we have tried to decode every single instruction, and I am pretty sure we have succeeded. I can tell you this is one of the hardest topic here to understand, or not the hardest, but one of the harder topics to understand. And it's not really necessary in order to create smart contracts. So you don't need to know anything about the bytecodes in order to create a smart contract or to work with smart contracts. But it's very, very good knowledge to keep in the back of your mind in case you will need it, or you want to have this entire picture how blockchains and how related technologies work. Okay, in this lecture, we'll continue. We'll be not doing here much here. I just would like to give you some of the resources you can study when you will finish the lectures in your free time, maybe when you will drinking coffee or having breakfast. All right, so first thing I would like to note here is RLP. I will be talking about RLP later. It's a recursive length prefix, and it is encoding. It's a main serialization form used in Ethereum. It's almost used for everything. For blocks, for transactions, account state data, and so on and so on. So basically what this will do, this will serialize your data of the blocks into this RLP format. So everything will be just a sequence of the bytes. I will show it to you, don't worry. Okay, first, maybe what you need to understand is what is the block header. So block header is this set of informations about the block. Many of them I have already mentioned. So let's take a look first at the block header. Okay, so I will copy this link here. You can find it in the resources of the lecture. Okay, and simply let's paste it here. Okay, and let's go down here. And this is basically informations about the block header. So the difficulty of the block, some extra data, gas use, the gas limit, recipients, and also all this stuff. I think it will format better for you. Let's write here what is block header Ethereum, and there is very nice image. I'll also include this link here. Ethereum block architecture. I think it's this one here. Okay, this should be also included in the resources already. And this block header are basically the informations contained in the parent hash, converse hash, beneficiary, state root, transactions root, recipients root, and all the informations are contained into the block header. So when the miner is creating block, the miner is forming a block header, and then also it's serializing it in specific into the specific format. Okay, so once the nonce is found, the block is formed with all of these informations. About some of them we'll be talking later. Some of them you already know: gas limit, gas used, beneficiary, parent hash. Okay, recipients root. That's actually, we didn't talk about this yet, but yeah, we don't need to know about that one just now. Okay, we can also take a look on these informations on the Etherscan. So we can go to Etherscan and let's search for some simple transaction here. So 267, that doesn't really matter. Just look for a transfer of money, just transfer method, and let's look for a transaction. And that's basically what you see. It's a block header information. So transaction hash from to, and all these informations. And when you want to see this data in RLP encoding, you can just simply click here on the right side and get a raw transaction hash. And this is encoded data in the byte format, as you can see. When you want to decode this data, there's also other link here, this one here, encoder, and we can encode this RLP encoded string. So here we will go to Ethereum, up here RLP, and here is a decode button. So let's click here, decode. Let's copy this string in hexadecimal format, and let's paste it here. Okay, I think we need to click here on transaction down here, transaction, and here, let's write here and decode, and let's paste here transaction here. Let's remove everything and let's paste it here. And you can see some of the informations are encoded now. So there's the address of the user. So let's see if it's right. So I will copy this address, address, and I will go here. And yeah, there's a address here. You can see from this serialized data, we could encode them. All right. Nonce is 10. Okay, so here I don't know if there is nonce 10. Yeah, here is a 10 nonce. And yeah, you can see it from this here. From this here, we could encode all of these informations. So this is just for you to know. And also this RS and this data, these ones are part of a digital signature because every transaction is signed to be verified. That's a very important thing. We didn't mention it yet, but I will be mentioning it in a later lecture. So all these informations we have from this RLP encoded string. That is a sequence of bytes. And it's also called block header. Okay, and yeah, this picture, yeah, I think we'll leave it this picture for the next lecture. I just want to show you resources in this one, but if you feel adventurous, you can, after lectures, you can take a look about this here. And this part here on the left side, it should be EVM, so Ethereum Virtual Machine, and it's running through the algorithm here, so through the proof of work algorithm here. Yeah, okay, I will be not mentioning it here. Let's focus now on the resources, right? So I will close this. Okay, so this is about the RLP encoding, and also here's a resource on a Medium post about RLP encoding, Ethereum Viewer Live. That's how the blocks are added live into the network. So this I was already showing you, right? So that's the real view, that the transactions are coming here, miners are taking them, ordering into the blocks. When it's added into block, transaction is resolved, and the state of Ethereum is changed. It's happening very fast. All right. Bits, bytes, words. This is information if you need more about bits, bytes, and what are the words. Okay, nice YouTube video, and here is about the EVM and the bytecode. So basically what I have already explained, but these more extensive explanations. And here is about the memory in a computer if you want to watch this. I guess I will leave it here. Okay, so you can check it out, and let's continue. Next lecture will be working on some practical stuff.